Good morning, everyone. This is Birdie from the Moralis events team, and today we have another workshop for the Avalanche Hackathon. So we have Discordian here from IPFS. Really quick, I also just want to highlight their prize for the hackathon, which is the best use of IPFS or NFT.storage for content addressing data is 30,000. So it's a great prize. We're really excited to have Discordian here, so I'll let him take it away.
All right. Hi, everyone. I'm Discordian, and I don't know how to get my slides on the screen. Oh, okay. Awesome. Thank you. Yeah, so hi, everyone. I'm Discordian, a community engineer from Protocol Labs, and I'm here today to give you an introduction to IPFS. And I'm getting used to the new slide thing. And so what are we going to be doing today? Well, we're going to learn about the core concepts of IPFS and why they're important. We're going to talk about what tools exist today to help you get started building. Then we'll talk about some possibilities, throw out some ideas that might be fun to build with the tech. Near the end, I'll tell you some resources you can explore into to learn more about IPFS, as well as where you can go to find our communities and connect with fellow IPFS enthusiasts. And finally, if there are any unanswered questions at the end, I'll try to have time left for you to ask them, and I'll do my best to answer them. However, if you think of a question while I'm presenting, please don't hesitate to ask it. There will be lots of time to answer questions during the workshop, so don't hold back. A key part of IPFS is that it's distributed. Currently, the Web 2.0 model is centralization. One single point can fail and entire services go down. As you get further and further distributed, your service's resilience increases as the users themselves are what are powering the service. First, we believe that only the distributed web can address the technological challenges of the future. With the planet increasingly connected with the web and data that circulates on it plays a bigger and bigger role. Data and knowledge are a couple of the most important assets in this connected era. Being critical to human development, they must be safeguarded, open, and in the hands of the people. IPFS is not the answer to all the problems, but it is the answer to some, and overall represents a solid building block in the Web3 generation, particularly when it comes to removing borders and silos for data. So, what exactly is IPFS? IPFS is the Interplanetary File System. What is a file system? Files and folders. Any file with any content. Why interplanetary? Because it was conceived as a way to upgrade the web in a way that would still work when the network stretches across planets. The idea being that if you're sitting on Mars, it may take 1 hour for a request to go to and come back from Earth. But if that content was already fetched by someone else on Mars, then it should not travel all the way back to Earth for it. And that feature should be provided transparently by the network protocol rather than by something on top. As we will see, IPFS is distributed by design. No central authoritative servers are storing the content, and no central server needs to be contacted to obtain the content. I'm going to explain the key technologies making this possible. In order to do this, let's think of the process we follow when we put our data online. Typically, you would upload the content to a server, a location. Anyone wanting to download that content will have to get it from that location. With IPFS, things are slightly different. In IPFS, you run an application called the IPFS peer, and with it, you become the server. You don't upload content anywhere, but instead add it to your peer and make it discoverable by everyone else. Any content that is published on IPFS uses content addressing, which is a way of referencing a piece of data by its hash. As we said, a file system has files and folders, and the web is no different. When we open a website, we are just opening some files, with the difference that they need to be downloaded from a remote location, and that we need to do that using a browser which will print pretty things on our screen. With IPFS, we are also obtaining files from a remote location, but the key difference here is that we don't need to know the location of the content, but what we call the content identifier. The content is still at one or several locations, but as we will see, it does not matter anymore where it is. We switch from a location-based identifier to content addressing by using a CID. In order to have content addressing, we need to obtain content identifiers for each piece of information that we want to put on the network. This is effectively a cryptographic fingerprint of that piece of content. Every piece of content produces a different fingerprint. All the fingerprints are of the same size regardless of the amount of content. This fingerprint, which we call a CID, can be reproduced anytime from the original content. This means that if we obtain a piece of content after requesting a CID, we can verify that we were given exactly what we asked for. So when it comes to files, the idea of how we address content from them is clear. But what about folders? Well, folders are just a special type of file, which have a list of files. So a folder is a special type of file which has a list of files in that folder as the content. That list provides the names of those files, and in the case of IPFS, their CIDs. Since a folder is a type of file, a CID can be obtained in exactly the same way as any other type of file. This means that we can represent a folder, or even a full file system, using a content address structure like this. As you see on the right, our top-level folder has a root CID. It has 2 entries corresponding to 2 folders, and those folders have other entries corresponding to files. Each entry has a different fingerprint, see the colors, as each fingerprint refers to different content. This content address type of graph is what we call Merkle-Daggs. So I see a possible question from Tippy. If it doesn't matter where the content is stored, is it to say that there is no distance data? Don't we want to get the closest file to us from the closest peer node? The way IPFS calculates distance is it's not by really physical distance, but rather, I think it's called distance under the hood. And I do get into that later a little bit. But more or less, there's a calculation run, and certain peer IDs have a higher chance, at least for DHT-wise, certain peers have a higher chance of having a certain CID. And then to answer Ganesh, I hope I pronounced your name correctly. How is CID for folders created? Yeah, so I did go over that a little quickly just now. But effectively, a folder you could think of as a file with a list of the files that are in it. So it'll have just like a list of CIDs and their file names, and that allows you to address content, so you can have a folder / the file name, and you could address it that way. But effectively, a folder is literally just a file that is a list of CIDs that are inside of it. And then you can compute the CID from that file, because you've now distilled it down to a file. I hope that makes sense. And then we'll go to the next slide. Oh, and hopefully this will help make that more clear too. Okay, so the Merkle-Daggs used by IPFS allow us to move from location-based addressing to content addressing in a single step by just replacing locations with the root CID of their content. The subpaths stay the same. One characteristic of content addressing that I mentioned is that the fingerprints are unique for any type of content. What would that mean if we wanted to copy file.txt to the folder of the second user? It means 2 things. First, we did not really have to copy the file. We just had to modify the folder to reference the content. Two copies of the same content have the same identifier. So to IPFS, they are the same thing. There is no notion that the same content can be duplicated in different folders in IPFS, because it is actually the same thing with the same CID. We call this property deduplication. So if you think back to what I was saying before, where like a folder is just a list of files, if you then wanted to reference a file that already existed in another folder, you're just adding the same CID, so you don't have to re-add the data. And I guess, to follow up with what Tippy said, he was thinking of download speeds for big files. That totally makes sense. Of course, when you're connecting up with other peers to try to retrieve your data, I assume with latency, the ones you connect to first will be the ones you start downloading from first. So I think that problem will more or less solve itself, but I'm sure there's more going on under the hood than I've explained here to make that better. All right. So secondly, we changed a folder. Secondly, since we changed a folder, the fingerprint of that folder has now changed. So we had to update the upper folder too to reference the new fingerprint, which means that the fingerprint from that folder changed, resulting in a new root CID. The moment something changes, you get a completely different CID. Your previous CID still references your previous version of that content, which has not been changed. The key fact that a CID will always represent exactly the same piece of information, unlike a location, unlocks the capacity of doing verification on any piece of data and makes IPFS a very good framework for append-only storage like blockchains or data archives. As you can see, content addressing is a nice drop-in replacement to location addressing, as we keep having folders and paths in a very similar way as we had them on regular web addresses. So the first step when adding content to the IPFS network is to obtain the content identifiers for that content. This can happen offline at any moment, and that's effectively what we just went over. But once we have those CIDs, the next step is to announce them to the IPFS network so they can be retrieved by other IPFS peers. But what is a peer? And what does it do? So peers in peer-to-peer systems are nodes that are connected to other peers to form a network or swarm. Forget for a moment about IPFS peers and think peers in general. There are certain features that a peer in this network must have. So first, it needs to have a name so that other peers can identify it. In practice, each peer has a unique identifier. This identifier is linked to a cryptographic identity, which allows each peer to communicate securely through an encrypted channel. Secondly, it needs to share at least some functionality with other peers. If a peer needs to interact with other peers, they will need to support the same services. For example, the peers in the IPFS network are peers which support a set of services or protocols. One of them serves to request certain content by its CID from a different peer and download it. But in order to get there, it means that peers need to be able to discover each other, the network transports that they support, TCP, Bluetooth, and the services they can understand. This step is called content and peer routing, and it is achieved through something called a distributed hash table. The DHT, or the distributed hash table, is a critical service that each peer runs. DHTs are the equivalent of a large database that works by storing only a small number of rows in each peer. In order to get the value associated to a key, a peer will need to find some other peer that is storing it. The process consists of asking other peers in the network, who has this row? But not in a random fashion. Remember that not every peer is connected to every other peer. Instead, peers with certain names, or peer IDs, are more likely to store certain rows. Thus, a peer knows which one of the peers it is connected to is most likely to have the value for the key that it is looking for. But what if it does not have it? Then it will request information about peers known by the peer, which are more likely to have it. Now that we have a database shared by all the peers in the system, how does IPFS use it? Simple. When the content is added to IPFS, a peer will insert one row into the DHT, mapping the content IDs that we generated to its peer ID, declaring itself a provider for that content. Publishing this row involves finding a peer similar enough to the content ID to store the row. In any case, the content ID is, however, a very small piece of information, and the actual content stays in the original peer. Peers also insert routing records into the database. These map their peer IDs to the locations where they can be reached, and the method effectively to their IP address and port. Any peer that wants to download some content will then have to do two things. First, query the DHT to find which peer ID is providing that content. Second, query the DHT and find information on how to contact that peer ID. At the end of the DHT queries, a peer knows who has the content it wants and where to get it. Alright, so now that we've gone over obtaining a CID, advertising it on the network, and locating content, let's take a look at transferring content. The last step to retrieve content in IPFS is to download it. Because we know how to contact the peer holding the content, we know what content we want. We can connect, receive, and verify it. This means that any content received through IPFS is authentic and matches the request. Once content is downloaded, the local peer will advertise itself as a provider for that content on the DHT, making it available to other peers for download. The protocol we use to download files is called BitSwap, and it works for quick discovery as well by asking all neighbors whether they have the content. So this would effectively bypass the DHT. If, for example, a CID was not published in the DHT. So in summary, putting together things like peers in DHT, which are provided by the libp2p project, IPLD formats, like the ones used to represent files and folders as Merkle DAGs, which is called Unix FS, and IPFS specific protocols like BitSwap, we have built a distributed file system. So a little bit of recap for this part, I guess. The IPFS peer is an application which you can run on your computer, which does all this and some more. For example, it exposes the HTTP API to allow other applications to interact with it, like IPFS Desktop, and an HTTP gateway, which runs a web server that can be used by a browser to access content from the IPFS network. The key facts here are that all content is authenticated when retrieved. Thus, you always know you are getting what you requested. There are no central servers, and content is always downloaded on request. Adding content does not require uploading it anywhere or even having a working internet connection. So what about the web? As you saw, we moved from a nice URL to a horribly looking CID thing. But I also told you that the IPFS peer runs something called an HTTP gateway. So actually, we can rewrite that URL in a way understood by the browser. And given that we can use DNS records to solve difficult to remember IP addresses from domain names, why don't we use those to resolve difficult to remember CIDs? All that said, since localhost 8080 is actually an IP address, why not configure my domain to point to it? So right now we have everything written, you can see on the slide. where instead of a CID, it's our local host address, which would be the IPFS peer hosted on our local PC, and then IPNS, and then it goes to domain name and resolves kind of normally from there. And so then we go to the next slide. And now we just have an IPFS powered website, fetched from any providers on the IPFS network through a secure channel. Authenticated as long as you trust the DNS, and served locally. But this is also a hack, as it makes it a requirement that everyone runs an IPFS daemon when visiting a website. The solution here, and what we do to run our own project websites, is to rely on a combination of public IPFS gateways and support from browsers and browser extensions. So in practice, what you can do is configure your domain to point to the public IPFS gateways and have the browser extension detect and decide whether that website is an IPFS available one. And if it is, and you're running the IPFS peer, use that to retrieve it through the IPFS network. And otherwise, fall back to using the public gateways, which gives you a very smooth upgrade path. In the future, we expect browsers to run directly an IPFS peer. This is already possible, but experimental using the IPFS companion extension. I actually use it daily, and I really like it. So if you're looking to try this out, I really recommend grabbing the IPFS companion extension, which I know works on Chrome-enabled things. I'm not sure if there's a Firefox one, but I still really recommend checking it out. And it is just called IPFS companion. Yeah, and basically that's how IPFS works and serves to upgrade the current web from a location address system to a content addressed distributed file system. All right, so by now you might be wondering, what can I build with IPFS? Well, we've been brainstorming some ideas to help you get started. We have quite a few, but I'm just going to briefly go over some. So here are 11 ideas of varying vagueness, difficulty, and complexity. And I'm just going to briefly read a short description of all 11, and feel free to ask any questions too. So you could create a social media website where data is shared directly peer-to-peer. Timelines decided organically by the data you literally receive in a stream, filtered by the client. Perhaps you'd like to start at a lower level, though, and design distributed social media standards, the very primitives other networks could build upon. A distributed video streaming service could be nice. Users could monetize their videos through a token, and maybe require some form of payment for certain content or extras. You could help cache the planet, help store popular JavaScript libraries over the distributed universe. An RSS emulator could be fun. Users could subscribe to a pub subtopic, which is a publish subscribe system you can use through your IPFS node. Peers could subscribe to a topic they're interested in, and another peer could publish updates to it. Decentralized achievements could be fun. Create a system where Web3 games can easily integrate achievements into their games, adding a whole new layer of fun to new Web3 games. You could make an app to simply snapshot a website and provide the immutable CID representing that website. Build the distributed metaverse, where any user can host their own planet, allowing users to colonize entire new worlds in an inexpensive and distributed way. You could build a decentralized service that assists you in purchasing the correct temperature of coffee. A distributed Git platform could be really cool. Bonus points if you can integrate an issue tracker into it too. A wrapper for YouTube to help cache videos onto the decentralized web could be absolutely invaluable in preserving certain types of content which are completely lost to time. Well, I hope at least one of those ideas helps spark your imagination. IPFS really is useful to anyone who wants to serve or retrieve content on the web, which is almost everyone. As certain pieces of content get more popular, the data becomes more readily available and resilient to loss. You can also run your own nodes on classic infrastructures like VPSs or pay pinning services to hold onto your data, ensuring availability. There are several layers to any application, and Web3 offers no exception. You have storage helpers such as Web3.storage, NFT.storage, Moralis, Fleek, Estuary, Infura, Ceramic, and more. There are so many tools out there for storage providing that finding the perfect fit for your project should almost certainly be possible. We have the logic layer as well through smart contracts that can point to CIDs served over IPFS stored via Filecoin, a pinning service, or maybe even persisted through sheer popularity. The logic layer offers endless possibilities with so many technologies, including Ethereum, Near, and many, many more. Finally, we have the front end. This is what you see, and can include typical Web 2 methods like throwing your page on a web server and having some server-side code do some work, but also Web 3, where the website is served over the distributed web, often with integrations like crypto wallets and NFTs. Serving static websites over IPFS is quite easy, so I hope to see more and more Web 3 type front ends as we move forward into the future. So I promised I would tell you about some of the tools to help you build your app. So now I'll go over a few of those. First up is Fleek's IPFS hosting. It's designed for fast, modern, censorship-proof websites and web apps on the open web and works with most modern frameworks. It works by connecting your GitHub repository and you add some build settings. From there, you can deploy your website to IPFS, which is backed up to Filecoin. You can find more about the services Fleek offers over at fleek.co. All right, looks like I might have another question. So Tippy asked, Discordian, other than IPFS Companion, which you use every day, what about IPFS Command Line and IPFS Desktop? Yeah, those are great. IPFS Command Line, so you'd be referring to Go IPFS. IPFS Desktop actually runs Go IPFS in the background. So these are actually, I guess, the bread and butter. When I talked about the IPFS peer earlier on in the presentation, all those run an IPFS peer. So really, at the end of the day, those are all the same technology. But I highly recommend, anyone check out IPFS Desktop, which will connect up with IPFS Companion. Or if you're more of a power user, IPFS Command Line, which is Go IPFS, and that will also connect up with the companion. So that should be a lot of stuff to play with. Oh, just a phone. All right. And next slide. Web3. Oh, I thought it was pre-recorded. Oh, okay, cool. Web3.storage is a powerful solution for hosting your data for free, backed up over Filecoin and available over IPFS seamlessly. Data is immediately uploaded to a hosted Estuary node and automatically stored with 6 providers around the world. It can be used a variety of ways, including the HTTP API and web interface. Yeah, sorry about my phone, it'll stop. There we go. All right, so NFT.storage is a powerful solution for hosting your NFTs for free, backed up over Filecoin and available over IPFS seamlessly. NFT.storage is designed for NFT developers who want free decentralized storage. You simply upload your data and get back an IPFS CID that can be used in on-chain NFT data as a pointer to your content. Storage and retrieval is free. You get properly formatted metadata back. Immediately after uploading, you can fetch it back via IPFS, and it's backed up to Filecoin via free storage deals. NFT.storage is easily used via its JavaScript client library, their HTTP API, or it can even be used as a remote pinning service. PowerGate. It's designed for developers who want powerful ways to connect and extend libp2p, IPFS, and Filecoin. PowerGate bridges to Near and soon ETH, Polygon, and others. It works as a Docker container wrapped around an IPFS node and a Filecoin node. It can stage, store, and retrieve data, as well as provide default configurations for miner selection. You can find lots more information about PowerGate, including usage, via Textile's website listed on this slide. Last but not least, there is Moralis. It's designed for developers looking for an all-in-one toolkit and service for Web3. For IPFS, it works as a simple call to save IPFS. There are other helper commands as well in the docs. I highly recommend checking them out. I've listed only 5 storage providers here, but from ceramic to estuary, there are many others to discover. Come learn and build. We have an awesome community comprised of builders who help us foster a positive and productive environment. I highly encourage you to check out a resource we compiled of several tutorials currently available at tinyurl.com/learn-ipfs-filecoin as well. I really hope to see you around, and I'll be available for the duration of the hackathon, so please ping me or send me a DM. I'm Discordian on related Discord servers and the Filecoin Slack. Yeah, I actually finished a little bit earlier than I expected to, even with the questions. So that's actually all from me. So please, I invite you to ask any questions that you have now. Well, it seems like everyone had fun at least, so that's great. From where should I start learning? Yeah, so I just mentioned a URL that you can go to learn. So you can see on this slide under learn, there's tinyurl.com/learn-ipfs-filecoin. We put together that page and it should be up to date. So I think that would be a good place to start. Oh, cool. Now we got a bunch of things rolling in. So we have oh yeah, you're a beginner. So yeah, that should have, honestly, it should have info. I believe from all the way beginner all the way to advanced. Then so talk about YouTube DL. Yeah, so YouTube DL is just an idea I threw up, but I can try to talk about it. Let's get back there. And thanks for all the questions, by the way, everyone. I really appreciate it. All right, so yeah, YouTube DL DWeb. So that would work. There'd be a few ways you could do it. So how I imagine one way that you could build this application, which is, I don't think it exists, or maybe some forms of it exist. You would point a YouTube URL at the application, and then maybe they could select what formats they want to download. Because if you've never downloaded anything from YouTube before, you'll find you'll get a bunch of different resolutions and even containers and codecs, and you can download different versions of the same video. So when you do that, you'll probably want to store some metadata with it as well. And then you'll have a CID, which will contain information about the video, like the video file itself, as well as metadata letting you know what resolution it's in and stuff. So 720p, 1080p, stuff like that. And then because then it's added onto IPFS and it'll be made available over IPFS. So from there, it'd be up to you what you want to do. That's how I see a really basic form, but you could throw a web front end on there. Maybe you could see recent ones that people have CID-ified. All right. So next question: what are some of the IPFS projects that you are working on / want audience feedback on? I guess I don't really need any feedback on anything because I haven't launched anything new recently. But one of the projects that I've been working on is IPFS Sync, which is a command line utility which allows you to effectively have a directory on your computer, and then you can put files in it, and it will add those files to your IPFS node and grab an IPNS address for it. So that way you can have a static link to files, and you just edit some files on your home directory, and they're automatically updated and synced. And then, so Franz, do you have a Discord channel? Yeah, actually, on the Moralis hackathon, or yeah, the Moralis Discord, which has the hackathon-related content on it, there is an IPFS channel on there. So I invite you to ask any questions in there. I'll be hanging out there over the holidays. I'll be popping in and checking it out too. So Janix, I have no experience in coding. How long do you think it would be able to start building Web3? I guess it all depends on how much time you have, and I guess if that's what you want to do in life. So that's a pretty broad kind of question. like some people I think could learn fairly quickly, and I think anyone who really puts their mind to it, like if you learned JavaScript, for example, if you wanted to build like websites, and then you started diving into different techs like the helpers like Moralis, I think you could get started in like as little as a few weeks. But you would have to put the time like learning JavaScript and stuff like that in. So now we have Curiosity Coffee Bar. So something I am trying to find and found this live stream is how to verify someone has a specific NFT to offer, say access to a section of your site to buy merch or redeem something. Yeah, I think that sounds like more of a blockchain type question to like verify if a wallet has a CID. So I'm sorry, I don't have an answer off the top of my head. Um, so let's see. Rigo asked, would an audio streamer have the same concept as a video streamer? Yeah, that'd be roughly the same project. Okay. Well, yeah, this seems good. It was a great time, everyone. I hope you had fun too. But I think that's all from me. So I will pass the mic back over to Birdie, I think. Thank you.
Awesome. Thank you, Discordian. Thank you, everyone, for joining. We do have another live stream starting in about 20 minutes. So keep an eye out for that. I'm going to send a message in the Discord. Please join our Discord at moralis.io/mage and check out the Avalanche and Moralis Hackathon. There's lots of great prizes, including the IPFS one, among others. So yeah, thank you all for joining today. And thank you so much, Discordian. That was great.